Hey, welcome back to the stream. Looks like we are streaming on the YouTubes and the Twitches. So today's stream doesn't have like a really hard engineering goal to it, although I do suspect we'll end up doing some debugging and some engineering work here. But it seemed like a few of us in chat at least thought it would be a good idea just to also have sort of a hangout / virtual hackerspace on Friday. I've certainly been a bit of a hermit all week, just working on video editing and just trying to get more stuff out. I just released another edited video today, so it does seem like a good time to do a stream and maybe do something else. So, welcome back, everyone. I think Tuco's already settled into a spot here. So, yeah, I think some people have been asking about the status of the robot because I haven't been talking about that much, or I've just been doing a lot of other things in the live streams, especially, and the short answer is that it's actually fairly stable, certainly not feature complete, certainly not utilizing all of the hardware I've got or doing everything I really want it to do. But it's been useful enough that I've mostly been using it these days instead of working on it, which has actually been kind of nice in some ways. But there's clearly a lot of room to continue working on it and try to make it better. The motion control needs work. It's obviously still a little bit wobbly, and I think some of that is just due to outright bugs in the software, and some of it is due to physical limitations that we can mitigate either with hardware or software changes. And I've talked about that before. The limiting factor right now in what it can do comes down to mostly just like being distracted and not writing software. I think the logic here, let me actually sit down. This is like super awkward. Tuco, oh yeah, hey honey. I know I stopped rubbing your head. Sorry about that. Well, there's not another chair within arm's reach, but I can just sit here, which is fine. Hey Tuc. He's being affectionate right now, which is... Oh gosh, he's been super purring. Like, he's a really quiet purr dude, you know, and I know cats purr for a lot of different reasons, but, you know, it's like sometimes you purr just because the situation is intense. Sometimes it's like kind of a stress response, but sometimes it's because they're just really having a good time. So it's always especially nice when, you know, there's a good mixture of like purring and then him like kind of rubbing his head up against you, and licking is especially good if he's like purring a lot and then like rubbing his head against you and then licking you. That's how you know he's really into it. Are you getting up? Are you gonna give me my seat back? And this is cool too. Oh yeah? Yeah, I've really got to get the editing speeded up. I tried to make a really simple edit where I didn't spend that much time in any kind of post-production, which didn't go as quickly as... And so that was actually not the most recent video, but the one right before it, the one on the little tiny reflow oven kit. That one I was trying to just go very straightforwardly from source material to edited video pretty quickly. Which was then still complicated because I was changing around my setup a bunch and upgrading my computer, which has been largely really positive, but just involved a lot of like stuff being in flux as I was replacing hardware and wondering if I broke my SSDs, and just going through all the hassle and stress of kind of changing around your workflow and hardware. But I no longer have the editing machine disassembled in the middle of the shop. Everything's back in the rack. Things have been pretty smooth. And so this is now 2 videos on the new motherboard and new SSDs, and so that's been nice because I no longer am just waiting on the disks and the CPU all the time, so I get to find out what the other bottlenecks are in my workflow. So I get to find out things like, oh, well, if you stabilize these little short clips, then it's fine, but if you try to stabilize like your entire raw feed, then you could leave it overnight calculating, and then it'll still just crash in the morning. So I learned things like that. And yeah, but it's been nice. Learning how to get better workflow in place. I just have such a backlog of footage, though, that it's like part of me wants to really focus on, well, like, what is really the message I want to send? What is something I can focus on, specifically scripting and filming and editing to put that message through. Versus what I'm doing right now is like, oh my gosh, I'm like neck deep in footage that I want to get out there. I just need to edit it and get it into a good format. So, trying to see how I can just like get back to some kind of parity there, so that I can then make progress. But I don't know. I appreciate hearing what other folks think. I think there is. I mean, like, I could just like declare footage bankruptcy and just like delete everything. But I mean, I think there's a lot of good stuff there that like. I mean, I have gone through and just like deleted large chunks of footage because I'm just like, I don't think I'm going to do anything interesting with that. But like, I think after rounds of doing that, still there's stuff where I think it's really worthwhile to keep it, and there's a lot of good stuff in there. So I don't know. I think a lot of it is just that I'm kind of burned out on the like just like technology enthusiasm kind of angle. And so if I can find some other angle, then, oh wait, I'm not the cat. Don't look at me. You're not really seeing this, but I'm looking at the debug view here, and it just locked onto my hat, I think. Yeah, no, that's the real cat. Pay attention to the real cat, please. Yeah, this cat's pretty great. Had a surprising number of people ask me about this little vice thing too. Yeah, it's like a weird object. I think I remember seeing it from another friend who has one of these for PCBs, and it's just like a weird object to see because it's like basically just a bolt. Like it's a weight at the bottom, and then you screw down a pad that sits on top of the PCB. And like you could make one of these yourself out of like hardware store parts. The thing that's nice about this is it's like padded so that it's very gentle on the board, and it's anti-static. You know, it's slightly conductive, so that it keeps static from building up. And yeah, it's just nicely made, but I mean, it's admittedly pretty overpriced. I think this is like $70 for this like admittedly really nicely machined hunk of metal, but it's just like a machined metal specialty tool. So I think I've seen some cheaper knockoffs of this, but I don't know much about those. I just got this on recommendation from a friend, and I've been pretty pleased with it, but it's not something I recommend for everybody. But yeah, I got a lot of questions about this because I think it's one of the sort of thing that doesn't really look like it should work from a distance. And the only reason it does work is because it's very heavy. So, yeah. So yeah, the cat's been great. I don't know, videos. Oh yeah, he's licking me now. You're such a sweet boy, Tuco. Can I get the camera closer? It's like a weird angle for the webcam. I'm a little bit too lazy to move the webcam right now. Oh, can we just have this maybe? That's not bad, actually. Got a good view of the robot itself. Yeah, so there are a lot of individual problems that cause the robot's motion to not be that smooth. I think I talked about that a bunch in the last Tuco Flyer video I did. One that I think comes to mind to fix just straight away is there's a specific problem with the firmware where I think it's oscillating in and out of like a dead zone mode, and I'll have to refresh my memory on exactly what's going on. And so maybe a good step would be to take a look at the graphs that are getting logged from the robot. Because right now, I mean, the robot logs all of its data into InfluxDB, and then I have Grafana set up to make it easy to visualize that data. It doesn't keep the data forever. I think I have it set to only keep the data for like a month, but it's got a lot of data there, still plenty enough to analyze individual problems that we're seeing. But yeah, it's also just Friday and a good time to hang out and work on stuff. So we can work on stuff together, we can talk, we can pet the cat. I think all those things are good topics today. Yeah, it's like the wobbliness is certainly weird while it's moving, but it doesn't take it long to stabilize. And when it does stabilize, it's pretty nice. Much more stable than you could get a quadcopter, probably. Like, you get good stable landscape photography with a quadcopter, but I think, like, indoors at close range, I think you'd notice all the wobble you'd get from the hovering. But I don't know. At the very least, it would certainly be noisy and would probably get attacked by the cat, whereas Tuco pretty much ignores this one. Hey, Tuke, are you purring? Oh yeah, he's purring. I'm sure you heard that chirp. I don't know if you can hear the purring though. I think his favorite chair is wherever I would have been sitting. That's why I really should have the habit of always putting 2 chairs out at every desk. Or at least, 2 surfaces that I'm willing to sit on, because I'm sure he'll take whichever one he pleases. Yeah, actually, if we were going to have like more of like a chat sometimes, it would be interesting to hear about other people's sort of motivations and hopes and fears around technology, because that's something I spend a lot of time thinking about, but I don't really know how to incorporate it into my videos or my content at all, really. Like, I feel like the motivations I had to get into technology were just like kind of weird and arbitrary. It's like I found something that I thought was interesting. It was like much better than the alternatives that I had, but I didn't really think through, how it compared to like every other thing you could do, or just like how it compares versus just like not doing it at all. I think my younger self had a lot more of the like, well, do it just because you can sort of attitude, whereas like now I'm more like, thinking about whether we should, and thinking about the implications of the things we are doing more, which is depressing a lot, but I think it's worthwhile. I get frustrated when people largely manage to avoid thinking about that. It seems to just be justification to just like defer responsibility to someone else, who then ultimately is going to either keep deferring responsibility or end up like basically just being corrupt, like misusing this extra power that they now have. Cats are nice. You got anything to say, Tuco? That was a slightly louder purr. Maybe you heard that. Oh, Tuco, your hands are just like hanging out there all beautiful. He's got such good hands. Yeah, I mean, like, I don't know. The thing that I'm most impressed by is that Tuco, I don't know, he just really seems to have a lot of different ways of holding and interacting with the bolts. Like, he catches them and picks them up with his hands, you know, in a lot of different orientations. Holds them with his teeth in different ways. He's very good at actually bringing them back. Maybe I should bring another chair over and dig into some graphs soon, but it is very nice petting the cat. I can switch to the debug view maybe. Oh, yes. The robot is like right in my face now. We're kind of right at the end of the end stop for the gimbal. Like, this is not a great angle for the robot, really. Like, really the best place for the robot would be pretty much right where I'm sitting. Can it be above my head? That's not a bad spot. No aperture science logo. Oh, on the droid. Yeah, I have not built an enclosure. There are a couple of 3D printing and CAD projects we could do. One of those is I could really use an improved pulley mount for the counterweight up there. Partly, I want to give it a compound pulley so that I can get kind of more travel out of the leash without as much distance without as much distance moved by the counterweight, because the counterweight is just like running into stuff. It's also kind of noisy because the cable kind of slips out of where it's supposed to be. Well, I say supposed to be as if it was really designed. The whole thing is like kind of thrown together because it was just something I needed in a rush. So if I designed it properly, it could be much quieter, and the counterweight wouldn't bump into my cameras. And then, pieces to put an enclosure on the robot, which would be the basis for any kind of decorations and like logos like Tuco Flyer or Aperture Science or whatever. Oh yeah. Tuco kind of different. I don't know, sometimes he does warm, sometimes he does cold. I think his favorite cold place to hang out is just to like lay on the concrete floor. But I think he's more often into warm. I think he's more of a tropical cat. So I'll more often see him on the server rack or like under the couch, like on top of a carpet square, but like under the mattress of the couch, like so that he's kind of like more insulated. He likes spots like that sometimes. Oh gosh, I'm gonna drink coffee because my throat is dry, and then I'm gonna be over caffeinated, and I'll talk even more than I already am. Oh yeah, just was asking if my cat catches mice. Has he caught any mice? He certainly would, I think, if we had any mice here. He catches bolts, which is the weird thing. Like he's really into playing fetch, but he happened to find these plastic bolts that I keep around my shop, and he's really just turned that into his favorite game, so that's like his thing. He also fetches other things. He goes out into the hallway in this kind of shared warehouse space that I live and work in here, and he's brought back the weirdest objects. Like, I think the weirdest thing he's brought back is not one, but 5 cigars across several different occasions. I would just occasionally notice an increasing number of cigars on the floor next to where Tuco would hang out. And they were not like new, fresh cigars. They were like, clearly they had been somewhere for a long time. But they were in this like cellophane wrapping, which I think was the thing he liked. He likes the crinkly plastic noises. Yeah, the place I lived in, when I adopted Tuco, the place I lived in then, which was like before moving here, they had mice there briefly, like pest mice, I guess. I don't know. I'm kind of a fan of mice. Like, I've had friends with like mice pets that I've really gotten along with. So I like personally, I don't know, I'd have a hard time considering mice pests. Like, I'm sure I would I would consider them pests if they were like eating my food and like pooping on my bed and whatever. But like, I don't think I'd want to kill them. And I think I had my neighbors or roommates or somebody, they were trying to get rid of the mice, and so they'd set up traps. I forget what kind of traps they were. I kind of didn't want to know, but I probably should have like known. I was just like really trying to avoid those roommates at the time. But then after I adopted Tuco, the mouse problem, they just didn't see any mice. I think the mice just decided to go elsewhere after that for their own health, I guess. But yeah, good question. Tuco catches a lot of things. I've not actually seen him catch mice. I think he dreams of catching birds. Like, he really would love to catch a bird. He sees them out the window here all the time. But we don't let him catch birds, partly because he can't go out on the roof, partly because he can't fly, and partly because I don't really want him to hurt the birds. He catches spiders sometimes. I like spiders also, but you know, it's like kind of hard to keep Tuco from catching spiders. It's kind of having trouble recognizing the full extent of the cat in this orientation, so you see the rectangle kind of select weird portions of Tuco. I'm gonna get so over-caffeinated this way, guys. Oh, hi from a 5-volt junkie. Well, hello, and thanks for hosting. Oh yeah, Tuco is so good. Yeah, he's just a really cuddly cat. He's very demanding sometimes. Like, I have this problem where it seems like he knows right when I'm getting into the most productive. It's like I could be just like wasting time on the internet and he'll leave me alone. I could be like streaming and he's mostly gonna play along. But then I'm like trying to concentrate, like writing code or editing video or something, and he'll just be like meow, 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 meow every like 5 seconds. And I just don't know how to deal with that. He's just like super demanding. He wants to play all the time, so like we end up playing a lot, but not as much as he wants to, I think. Oh no, Vince has mice in the car engine bay. That's a terrible place for mice to live. Yeah, I live pretty close to a bunch of like biotech. They probably have a lot of mice. Oh yeah, Tuco. Good tail waggler. Oh yeah. Are you gonna pull the windscreen off, Tuco? Your claws got on the windscreen. Dude. Okay, I hope that wasn't too loud. Yeah. What a cute dude. Yeah, so obviously one improvement would be being able to move the camera around via chat controls. And there are a few prerequisites, but I think the biggest one is just generally the robot having a bigger kind of sense of awareness over how to limit its own movements to not damage anything. So, like it's got basic acceleration limits right now, but it needs more of an understanding of how to keep the robot from swinging, how to handle like kind of more dynamic movements without either having false positives or being like unable to sense problems. It needs to really I really need to work on the obstacle sensing, which probably also involves doing a little bit of CAD and 3D printing to improve the mounts for the IR sensors from what they are right now. Oh, yeah, Thomas says this is maybe a cat petting ASMR stream. Yeah, it certainly could be. I'd be into that. Maybe we can try a more vertical angle and get more cat. No, other way. Other way. You might hear that buzzing. That's the gimbal. It's like, oh yeah, it was like on the verge of being unhappy. Oh no, now we've got all the mice horror stories. Oh, Nemo Corey likes the noise and the winches. Yeah, the noise, I mean, the noise is related to some of the bugs. Some of it is intentional, but like the kind of jittery noise that it makes as they're stopping, that's actually kind of a symptom of this bug that I want to fix in the firmware. Yeah, there's a lot to do with the winches. Yeah, I've been part of why it's kind of stalled at this point briefly is because it works pretty well as is, and there's also just so much to do as far as improving it. So it's like one of those branching points where kind of choice paralysis can take over because there's so many things to work on suddenly, and the priorities kind of flatten out a little bit relative to what was there before. Oh gosh, but right now I'm just so distracted by this like beautiful cat that I have right here in my hand. So got a happy Friday from the Yeti. Happy Friday to you too. Oh, I can hear Tuco purring again. I don't know if any of that comes through. I guess I would know if I was wearing my headphones here. It would also help if I stopped getting the wire for the headphones. I think if you hear that background hiss that cuts in and out, that's the radio on this transmitter. Tuco's purr is so quiet, and this microphone is not very good at picking that up. Oh, we could switch microphones, but... it'd be easier to hear him myself if I wasn't wearing these headphones. Oh, he is vibrating really nicely. Man, I wonder if I could hear him purr with that light microphone that I just did the video on. Could we try that? Is Tuco gonna leave if I get up to set that up? He might. Yeah, like, I wonder how much of that I would get by passing a light through Tuco's fur as he's purring and picking that up with the light to sound kit. Like, there'd be a lot of bass as he's breathing, but I think the higher frequencies might capture some of the purr and other noises. It'd be tough to keep it aligned. I'm slightly allergic to cat hair, which Tuco has a lot of that is shedding right now. Hey, Fuzzboy. I'm just thinking about how to best... I mean, this is a problem I think about occasionally, just like how to best like put a microphone on my cat. Because like he's quiet, there's a lot of just general movement and rustling noises, but there's also some really, really good noises in there that it would be nice to be able to capture cleaner recordings of. I've got some alright recordings of Tuco that I made just from following him around with a lavalier mic on his collar and a short wire going to a recorder that I was carrying. Yeah, I think that approach is not terribly bad for kind of lower sounds too, because it does kind of press against Tuco a little bit, so it gets the like more vibration-y noises. Oh hey Tuc, are you gonna give me my chair back? Is the camera gonna lose you? Yeah, Tuco's way over here now. Tuco's getting a bite to eat. Alright, well, he's given me my chair back. Let's take advantage of this opportunity. Oh, it's so warm. That's great. Tuco, good job. Alright, well I think we want a different user interface here. So this is OBS, Open Broadcast Studio. It's the same open source software that I use for this stream. In this case, it's another instance which is running the computer vision. It can also do recording and streaming along with these overlays. So that's what it's doing. Then we've got a web interface which is connected to the daemon, like the background process that actually runs the robot. And that background process is also running on this same computer. It's written in Rust. This front end is just like a JavaScript client that speaks over a WebSocket to that Rust backend. So, yeah. We've got an authenticated connection to that, which means we can control the bot. Let's make some room for this. You know, I should probably be recording this screen. I don't want to take today super serious as a filming day, but I should at least be running the full screen video recorder. I was just trying to use the like face sign-in camera that I showed on a recent previous stream, and it does not seem to recognize me wearing a headset and a hat, which is maybe one problem. And now we're getting into Wobble Town. Yeah, the wobbling gets pretty bad when there's like kind of a compounding of factors. Like it's already a little bit wobbly, and then it kind of adds additional energy by trying to move it. And then it gets especially bad when the tension is not balanced across all four chords, and it's effectively just hanging on three of them. Okay, here we go. Hey, Tuco. Alright, so we can manually move the joystick. Oh, is Tuco heading for the frack? You gonna jump, Tuc? Oh. He's taking a sec to look through that gap in the window there. Or gap in the curtains. And we can drive the robot. Yeah, see, it's got a whole tension problem right now that it should be trying to resolve instead of letting me move at all. Can I illustrate that? Yeah. Just pulling on the cord just a little bit to give it like a non-zero amount of tension. It still doesn't have enough tension to really reel itself up normally. Try to show you what this looks like in real life. So there's the winch in that particular corner. It has not enough tension to run, which is why it's obviously slack and flashing red. And so that's slack, but still headed up to this pulley. And then down with still not enough tension to the robot. So, yeah, there's a lot we could say about problems like that too, in terms of fixing them as well as avoiding them. Right now it's just not very smart about that in general. So I'm going to manually pull on this a little bit. That's not the right camera. That's better. Of course, as I let go, I'm sending a wave propagating down the string. I'm always losing the remote control. It's all the way over here. So yeah, I think it's just not it's not moving. Like it's got a very simplistic way of assigning some intended motion to a command for all the winches, and in this orientation or in this pose, it's just not sending nearly enough of that command into this corner winch, and so it keeps getting under tension. So yeah, I think the first thing to do is to just fix this overall extreme jerkiness that's caused by, well, various things, but I think the first thing to look at is the lack of, or the like bad hysteresis in the firmware. But yeah, just looking at maybe the first derivative of the force on all the winches and trying to figure out how to regulate that might be another thing to look at next. Let's see what kind of data we're getting right now. I'm gonna put some more hot water in this coffee. Oh gosh, I'm gonna just, like, I think I need more warmth and less caffeine, which is really the thing. Maybe that means I should be drinking tea. Oh yeah, man, that rack, it's got a surprising amount of equipment. Like, it's funny because like I just put a bunch of additional discs in the rack, and nothing seems bigger. It seems like everything is exactly the same size, but has a bunch of additional discs now, which is nice. Oh yeah, I dash disabled physics. I should compile it that way next time. Let's see, anything else we can glean from the computer side of this? So this site here, this is like custom JavaScript. Well, it's not that custom. It's like React with a couple of custom React components. This was like my one React project so far. This is me learning React, but yeah, it's got a live WebSocket connection to the Rust server, and it gets these kind of high bandwidth telemetry feeds, which it then plots using smoothie charts. So for each robot, for example, you can get sensor data, motor activity. You can get, I mean, this stuff actually might be nice to look at, just moving the robot around. So yeah, here I am just holding the joystick at a pretty much constant level, which we could see if we were graphing the joystick itself, but we aren't. And yeah, there's already a bunch going on here. There's oscillation on that blue channel. I don't actually know off the top of my head which channel is blue. It'd be cool if there's a legend here. Yeah, so like we could look at it through this lens, which is helpful for just individual, like what is going on here with those velocity pulses? This is bot 0. See, there it's smooth. But yeah, I think a lot of that is the bug I'm talking about. You can see the velocity pulses match the noise as it kind of ramps down too. Man, okay. And this is the output side of that same winch. Yeah. Yeah, this definitely needs work. Okay, let's look at the other data. Oh no, it's 3,000. All right. Let's it takes up a lot of CPU just having this page open, pretty much no matter what you're doing with it. You can see the slight wobble very precisely as measured by the robot's IMU. Bunch of lasers we're not using yet. Okay, so what did I put on this particular dashboard? So this is Grafana, which is like a metrics dashboard kind of thing that you can use for monitoring servers or applications or people clicking your clickbait or whatever you want to use it for. Like it's really popular for just like ops and just monitoring your hardware and software deployments. There's a bunch of plugins you can use along with oh geez, I'm actually not an expert in any of this. Like I learned pretty much all of this just for this project. And there's actually there's like a collection daemon I've been using. I think that's chronograph. No, chronograph is the anyway, there's the database is InfluxDB, which I did not mean to search for just influx. So this is the actual kind of time series storage backend. You give it data points, and it stores them much like MySQL or any other kind of client server database. But in this case, it's here we go, tick. All right, telegraph is I think the part I was spacing out on. Yeah, so I think the typical way to use this is InfluxDB is your storage. Telegraph is where you put plugins in to kind of collect data from your operating system or your disks or your server logs or whatever. There's also capacitor, which I know very little about. I think that's like if you want to page people or like turn servers on or off based on the data or stuff like that. And then chronograph is actually an alternative to Grafana, if I'm remembering right. So you can use that to set up these other components. You can also just use it to graph queries from InfluxDB. I was kind of having trouble with chronograph at like kind of precise time resolutions. I found it easier to graph like fast changing data with Grafana, but like maybe I just missed something. In any case, I've been using Grafana for this and it seems like that's working pretty nicely. So it's a variant on the stack that you'll see here where I'm using InfluxDB. I am actually using Telegraph, but only to just monitor unrelated stuff. So that's not really part of the Tuco Flyer monitoring. And I've been using Grafana to visualize it. And then the Tuco Flyer daemon itself connects directly to InfluxDB, much like Telegraph would in this case. And it takes the same data stream that would be going to these graphs here, processes it a little bit internally into just the endpoints I care about storing in InfluxDB, and then it takes batches of that data, reduced a little bit, sends it to InfluxDB for storage. So that's where this comes from. It's going to be a little lower resolution than the stuff you see here, but it's stored longer term. So you can see just how much data is going through, the result of the computer vision. You can just see what the gimbal's doing, which is useful. Temperature, forces, accelerometer, flyer. Yeah, I think we mostly want to look at the winch behavior here. So So we've got graphs for the individual winches. There's also this overall winch PWM and winch force graph, both of which might be useful. All of these share the same x-axis, so we can use any of them to zoom in and then compare the data across data sources. Let's just look at... Well, actually, let's use this this range here to just look at the last 15 minutes. Oh, so that was taking a sec to, it's like it does all the queries asynchronously, but then I think the browser was just bogging down for a sec, and it caused me to click something I didn't mean to. But yeah, here's 15 minutes. You can see the flyer moving around and wobbling a bit. So what would be a good example? These blocks where I'm kind of moving it, I think this is where I was being successful at moving it relatively smoothly. But this looks like more of a problem. Let's look at the problem. Yeah, it's definitely got this chatter here. And this is just full of it here. Yeah, let's try to see what was going on here in this movement. Oh yeah, Martin's wondering what I do for a living. I mean, I'm doing this full-time right now. I've done a bunch of other stuff, mostly software and hardware, but yeah, no, I mean, right now I'm doing the Patreon-supported video stuff as much as I can. I should really pick on a more specific incident here. This might be a good example. Oh gosh, or that. Yeah, what's going on here? Oh, David is saying that this this tick stuff is kind of like SNMP. I mean, yeah, you can use it with SNMP for sure. If you have existing, like SNMP is a way to get like monitoring data from routers, for example, or like other network appliances. And so if you have stuff like that, you can certainly ask Telegraph to query that hardware for SNMP data. So it certainly seems like this problem is really about winch 2 here. So what's actually going on right here? So orange is velocity, so that's going to be measuring the actual motion. So something causes us to reset the position error integrator right here, which causes us to just immediately stop powering the motor, really. And so its velocity naturally drops, but at a little lag here because that takes some time to physically take effect. Actually, what is the lag there? Like 40 milliseconds. It's not too bad. Okay, so why would this be resetting? It could be the lower force limit. Oh, okay, this is not the hysteresis problem, but this might be worse than the hysteresis problem. Yeah, this is definitely a problem that it's having right now. There's really no soft kind of continuum between the mode where it's being affected, or where like a winch is being affected by the force limits versus by the kind of regular like PID loop input. I think I've experimented with having it not reset the integrator when it enters the low force cutoff region, but I don't think it actually kept up. Maybe we have to I think I need to refresh my memory on the code behind this. Oh yeah, David was pretty much on the right track, although it's not a force overload, it's more of a force underload. Okay, well this is a problem that certainly needs to be addressed, but it wasn't actually what I was looking for just now. Because I think it still might make sense to address the firmware issues first, just because that's lower level and kind of requires more time to fix, so I'd rather get that out of the way. Okay, 15 minutes is no longer as interesting. What's going on in 30 minutes? So really, I'm looking for that kind of weird, kind of jittery pattern on the PWM, especially as we're ramping down in speed. Let's just look at some of these. Yeah. So, like, we could look at any of the winches here. How about winch 2? Yeah, so this is something that happens kind of in that zero crossing between like a negative velocity and a positive velocity, or vice versa. As it's close to zero, we kind of keep turning off because the dead zone there. I forget exactly how the filtering for this works, but it's completely insufficient and it really needs to be replaced. Can we zoom out slightly here? Alright, so the blue trace here is filtered position error. And then this is output PWM, which is pretty much proportional. Yeah, I should reread the code here to see exactly how the dead zone there is calculated. Oh yeah, this is still a Robot Odyssey stuff. Folders. That is some good cat though. Let's just get a closer view. This will also be a fairly controlled motion maybe that I can use for data. Gotta let the browser catch up when I zoom in. It just is unresponsive for like 20 seconds or something. Okay, not 20 seconds, but... Okay, so there's the input. Message bus is keeping busy. Yeah. You can see on the gimbal control where it starts compensating for the oscillations. Also the power going into the gimbal motors. Winch forces, which is especially relevant when we're looking at the low end here, like winch 1. I think winch 1 is going to have oscillation problems there. You can actually, well, I mean, you can see a lot of oscillations here, but I'm wondering if some of these oscillations here, once you start hitting the low limits, are related to the problem that I'm trying to go after right now. And then there's all this. It's like interesting how early the oscillation here starts. Yeah, where does that come from? So this would be in not the controller, but the firmware. Do I not even have the firmware checked out on this computer? I was doing the programming on that from a Raspberry Pi. Alright, let's check it out here. We could also look at it on GitHub. Are we updating the frequency each time? Where does that happen? Okay, right. The firmware is not processing PWM at all. Or, I mean, it's doing the PWM, obviously, but it isn't generating the PWM frequency. Because I was pretty sure I would want to change that code without having to reflash all the firmwares. And it doesn't really require any kind of fast reaction time or, tight control loops there. Okay, well we can put that off because I really do just want to focus on just the firmware related problems right now. So if the problem is just the PWM frequency, there is a category of problems that will just manifest as the PWM frequency oscillating, but I think it was also maybe an indicator of something I wanted to look at here. Anyway, this position error deadband, I think that's what I was trying to deal with here. So is deadband if either the position error is outside of this threshold or the velocity is outside of a threshold, then we don't allow it to go into that deadband state. I think this does end up influencing the PWM control loop. It's just not directly in the firmware. I think that ends up going back to the bot controller and causing the integrator to reset. So yeah, we're seeing this around that zero crossing when you're going slowly. So if you were to go quickly, then I mean, is it possible that this velocity deadband should be smaller? It really seemed like this algorithm needed to change, though. Okay, what do I actually have those values set to? I even make the deadbands editable there? So this is in the firmware, right? So this does not have direct access to anything except the UDP packets coming in and local hardware. So it's getting its idea of the deadband from these per packet values, which we're then sending out from the Rust code. So let's look at where those come from. So, man, it's been a while since I've been in this code. So the messages that actually get sent out. This winch deadband structure. Yeah, and so this is reading it from the main config file, but doing a unit conversion on it to convert it from meters per second to calibrated units. Is this working? This should basically disable the firmware deadband if we're, I'm assuming this is actually 0, if we actually ascending velocity that's non-zero. Let me see how well that squares up with my understanding of how to interpret the data right now. How can we modify this? Wasn't there an easy way to bring these in from elsewhere? Yes. No. I kind of just wanted to duplicate this. Oh well, I don't need to fuss around. I was going to see if I could customize this a little bit for this particular debugging scenario. Oh, maybe I still will. So controls, because like this stuff, I don't really need this right now. This is like the kitchen sink dashboard, really. Okay, controls. Yeah, it takes a little while to zoom in with all these graphs open. So I'm going to zoom in from just before I issued the command to just shortly after the oscillation mostly stops. So I'm like kind of tracking down this trail of hysteresis oscillation in the firmware, and I'm actually like wondering if I should switch to a different problem because that doesn't seem to be as significant as I thought it was. If I'm understanding this right, we should only be using the dead zone at all when the command is 0. So really like this region over here that I'm not going to zoom into right now because I don't want to wait for it, but starting from right here and ending wherever it actually stops moving. So this stuff could be the hysteresis oscillation, or in part, but what we're seeing here mostly is the PWM frequency jittering up and down, which is itself not really a problem, but I think it's the symptom of something that I'm actually concerned about. And then this stuff here is, I think, it oscillating against the low force limit, which is definitely a problem. Is this it? Oh, I think that's dead zone oscillation on winch 1 at the end here. Okay, and this little bit here with winch 0. Okay, it's there, but it's not that big of a deal. Maybe that it too. Okay, well let's maybe shift to looking at the PWM frequency oscillation and what that actually means. So where is that being calculated? Oh, is this just oscillating between the high motion and low motion thresholds? Because this is a very similar calculation to the way the dead zones in the firmware work, but it's definitely different. Yeah, maybe this isn't as big of a deal though. This is based on what velocity? It's based on that unfiltered velocity reference. I mean, I have to unify these two dead zones, right? I mean, I think the one we're calculating in the firmware is better than the one that we're using here for PWM purposes. Donald is wondering if smoothing the PWM frequency would do anything. I don't think that's that's not really what I want to do to solve it, but I mean, like if like that was not a symptom of a problem but was the actual problem, then sure, maybe. But I mean, I think I'm using that as a diagnostic tool more than I'm actually treating that as a problem. And David's mentioning that the ClearPath servos have like a PID training mode. Yeah, that could be neat, but I mean, like this is also not, to be clear, like just like the PID. This is like that would be cool too. The problems that I'm seeing are kind of like adjacent to the PID loop. They're not really part of it or like orthogonal to it. They're just like in neighboring subsystems. Yeah, this just looks like more like control loop oscillation, but it could be coming from elsewhere in the system. Got a comment on YouTube wondering about from Dutch Ghost, wondering about just like the upsides and downsides to Rust, I guess. I don't know, I mean, like, I don't really like giving people like quick sound bites about languages, because I think usually like choosing a programming language is a pretty nuanced thing, and people who want sound bites are usually not as interested in the nuance. So I don't know if I even want to go there, but there's a lot that I like about Rust. I also think that generally, like, you should pick the language that fits your needs, and that depends a lot on the specifics of the project. Like, I think some people like making an identity around programming languages, but I don't know, programming languages are tools. I certainly like some of them, but I think just like the last couple of experiences I've had with Rust, some of the particular things that have caused me to choose other languages for a particular project where I would have otherwise wanted to use Rust is more like, you know, if it's a project where most of the code that I'm interfacing with is just like a big pile of C++ code, for example, I don't necessarily want to like have a language barrier in there between all the other code and this one new thing I'm writing, unless I've got a good reason. But sometimes there is actually a good reason for that. Like if you're writing code where the memory safety or integration with, you know, Rust's library ecosystem causes it to be worth paying whatever penalty ends up being there for maintaining, you know, a glue layer between languages. But it's just so specific to the individual project. Like, I could see making that decision in two different ways, just depending on the specifics of the project or the amount of time I'm willing to spend on the project. And it wouldn't really have that much to do with Rust or the other languages involved. So yeah, I mean, I guess that was a long-winded way of saying why I don't like the question and giving you some partial answers. You know, I think maybe we should just start with tuning some parameters. I think that might help us be a little more sensible. Cause like I don't want this PWM to be all over the place like this. Do we not have... Oh, I put a lot of them under this section. Yeah, that should be a lot smaller. I'm forgetting why the filtering is so asymmetric here. Why did I do that? Is it actually a reset, or is it just an asymmetric filter? Oh, it's symmetric, but it's filtering the reciprocal of what we're seeing here, I think. about that. That's different. Aiden's wondering if I can put a percentage done on the bot controller. I don't know. Feels like about half done. Oh, Martin says that the cat cam seems like a bunch of projects smashed together. Does it? I mean, all of this is pretty much doing what it's designed to do. I guess my answer there is that, yeah, the end goal here was the cat camera. Like, that's always been the point. And have I crashed the flyer yet? I mean, I've hit my head on it. I haven't, like, damaged it yet. I've been trying to be pretty careful with it. Let's see what some of the data for that looks like. Can we see Tuco in the data? Oh, we can actually. When this orange line is low, that's when we have Tuco in sight. Yeah. So the green line is the quality of the rectangle tracking. So that's basically a measure of how much contrast there is around the tracked area. And then when this orange figure, the tracking age here, is low, that means we've seen Tuco recently. And so it just resets when we've seen Tuco and climbs otherwise. And then here's, do we have the controller? Controls are down here now. That's interesting. Why did we get this frequency bump without any controller activity? I think that might have been due to chord motion, actually. Like, the motion threshold might be low enough that just other parts of the system moving can cause the chord to stretch and move through the encoder just enough to get a little bit of motion there. We're definitely getting oscillation on the finishing end here, as well as like in the middle here. What does this look like? Yeah, I've spent a lot of time on this project. I mean, I haven't really been keeping a log of hours or whatever, because that's not the kind of person I am, but like, yeah, it's something I've put a lot of effort into. This is neat too. Winch 0 has a nice curve, and then it's got this little bumpy oscillation. And this is, again, this is like the actual hysteresis that I want to add to the firmware would take care of this, I think. Oh. This has got to be the force limit, though. Winch 3. Distinct problems here. This orange trace here is winch 1. I think I just want to calculate the PWM frequency completely differently. For some background, the reason I'm changing the PWM frequency at all is to help the motors mechanically avoid static friction at low frequency or at low speeds. So that at low speeds, I would also use a low frequency. But at all other times, I basically want to use something that's inaudible. And there are a lot of different ways to achieve that. I could just instantaneously switch between two different set frequencies, and that would accomplish this. The way I've been doing this is by kind of having two different modes. Either you're moving or you're not moving based on a single threshold, which is part of the problem. And then, depending on whether you're moving or not moving, there's a filter which either approaches one frequency or another frequency. But that filter is actually not operating on the frequency, it's operating on period, which is why this looks very nonlinear the way it operates now. We could actually play with that behavior by changing some of the parameters. I think if we actually made the filter parameter large, like, I mean, it doesn't have to be 1, but we could make it 1 if we wanted to. I don't think we want to go any lower than like, actually, I don't think we want to go much lower than the control loop frequency. Which, how fast is that? That was like a couple hundred hertz. I'm gonna go a little lower than that maybe, but... And we don't necessarily want this threshold to be like completely stopped. We want it to be like, I mean, maybe we do. Because as soon as we have any detectable motion, especially given the whole system's latency, then it's like fine, we can switch to the higher frequency. There's maybe a bit of an effect to worry about from the motor's inductance in addition to static friction that would maybe make the lower frequencies useful, but I don't think that's significant enough to worry about. What does this look like? So some winches end up staying in that low speed operating mode kind of longer term, which is why you hear one of the winches kind of groaning. And then you do still see the oscillation between the low and high frequency modes there. Martin's wondering what problem I'm trying to solve. I'm trying to make the winch less wobbly. Specifically, the problem I'm trying to solve is when you move it, the graph is not smooth. It has chattering behavior, and I'm trying to isolate several different root causes for that behavior. One of which is related to a known bug in the firmware, which I thought would be the first thing I'm fixing. There are several other root causes. I'm trying to just isolate them. So that's why this is not straightforward. It's like just fundamentally not straightforward. I'm trying to tease apart different root causes for a subtle bug, so hopefully that helps. I don't know. Which velocity is this using, though? Because this is not using the filtered velocity. Maybe it should be. At least I don't think it's using the filtered velocity. This is a filter that's used for the lighting, but I think it shares a parameter with another velocity filter, which is why this is a more generic. Oh wait, no it doesn't. This is actually in the lighting configuration. But I think this is unfiltered. Yeah, this is the specific velocity we're using, which comes directly from the winch. Are we converting units? Oh yeah, that's the unit conversion, so that's pretty raw, pretty low level there. Yeah, so we have a filter for lighting. I don't think we have a general velocity filter there. The firmware has a velocity filter, doesn't it? Not that it really matters that much here. Let's experiment with these parameters some more. Like, part of this is wrestling with the question of, well, what should the winch do during the moment, however long this moment should last, where it's trying to get the load started, but the load is not moving yet? What should the winch do? What should it sound like? How long should it be trying to do this for? You know, should it be quietly burning power, just like kind of holding the magnet up against the load? Should it be buzzing in an attempt to kind of wiggle it free? Should it buzz but have a limit for how long it stays in that state? Can I just make it overall quieter? Oh, that seems actually much more effective. It sounds weird, but it's working nicely. It's really like jerking it to get past the static friction. Yeah, well, maybe I will solve this particular problem by filtering the velocity measurement that it's using. I just don't want to just like keep adding filters all over, so I would like to try to simplify this as I add to it, if that's possible. What was that just about? I'm just looking at one winch right now. It sounded like a lot of that noise was coming from winch 1. Oh yeah. that as a problem. Well, that's a strong indicator that this is related to position error dead zone. That is the position error dead zone oscillating. Is what this is. It kind of just, it like happens in different winches depending on the weight distribution. So I should remind myself because like there's no legend. This should really have a legend. I should just read the source code to remember exactly what all these values are. Okay, this is the winch PID page, and that's the position error and filter graph. So this is the source for that graph. So this is just a line at 0, and then this is like gray, and that's, if we scroll all the way over here. Okay, this is the gray line is the unfiltered error, and the, what is this? Kind of blue-green line is filtered. Huh. Okay, well I was momentarily having trouble reproducing it on this winch because the problem keeps moving to different winches. There we go. The gray line does not return to 0, so it is not subject to the dead zone, which leads... I mean, it's acting like the gray line is filtered right there. Did I get that backwards? This is gray. That is not the filtered one. So that's interesting. If I'm reading this right, then the filter output is oscillating, but the filter input is not. Scale ends up a little messed up because of some spikes up at front. Okay, like right here. It's definitely oscillating on the blue line, the like blue-green line. Yeah, let's just look at how those are calculated again. This, other than the unit conversion, I think this is coming straight from the firmware. Yeah, winch status message. This is just a packet that we get back from the firmware. So we're passing it through a unit conversion function, but otherwise this is just straight from the microcontroller code. Position error and pause error filtered. Oh, okay. Right there we're using position error just to see which direction we're moving in. Alright. Yeah, so position error itself does not include the deadband. Internally we have this position error with deadband. Which we use to update the filter. This is why the integral error is not oscillating. So the most straightforward change that I think, so that this does point back to exactly the bug that I thought we were going to end up having to fix today, which is a bit of a roundabout way of getting there, but yeah, I think this does point to a firmware change to add hysteresis to the deadband. We could implement hysteresis on the other side, like on the bot controller side, but it wouldn't be able to react right away. Like I think the best way to do this is probably to store this flag to indicate whether we're in the deadband. And then, oh, well, you know, actually, I mean, I like to design this so that the winch controller is pretty self-sufficient, but it's also true that it's basically in lockstep with the bot controller, and so we can rely on like a single frame round trip. So if that deadband flag was propagated out to the bot controller, it could choose a new deadband for the next packet according to the hysteresis. It would, you know, it would have a like a smaller deadband if you're outside of it, but then as soon as you get inside the deadband, it would start sending a wider one, so that it would then kind of discourage you from oscillating across that boundary. And so where do we do with this flag? Do we only use it here? We're only using it here. Yeah, so like we could get away with doing that. I'd rather not. I'd rather just send two positions and two velocities, just expand the deadband packet to have like min position, max position. Oh, what do we want to call those? Because they aren't really positions. It's like a position error limit. Yeah, like the hysteresis on the position error is not nearly as important as the velocity hysteresis here. Well, yeah, we should get back on the Raspberry Pi where we were doing the firmware development for this. Oh, cool. Glad the web app is helpful. Yeah, I certainly learned a lot trying to put that together. Okay, I've got a Raspberry Pi with an unrelated circuit on the breadboard. You'll just unplug that. I'm not really sure if this one's going to come up on the network in a place I know about it. Let's find out. Raspberry on a board here. Yeah, one thing I like about Rust is it feels like it has a good level of opinionatedness about threading. So like, I think Python makes some decisions about threading that were, like, I don't know if a lot of people like those. I think they were not necessarily intentional, but were just like a side effect of how the language evolved. And then C++, you can do so many different kinds of threading models with C++. So many. You have a great amount of flexibility, but it also makes it hard to integrate code from different people together safely in multi-threading environments sometimes. Like typically you'll find the kind of cross-thread communication, if any, isn't really part of the library itself. It's something that you have to add on yourself because like C++ libraries especially try not to be opinionated about threading for the most part. Whereas Rust, I think you'll find a lot more like interoperability in terms of multi-threaded libraries and programs because, well, libraries really, because you have enough kind of, enough stubbornness like built into the language and the standard library about how threads should be communicating. And I appreciate that particular set of design decisions they made. Alright, can we SSH into this? I guess I need a terminal. No, I thought that was... Okay, maybe not. I think we need a hard line. That's what kids call HDMI cables these days, right? Gotta patch it in. Gotta pickle those packets. You can pickle a packet, but don't packet a pickle. Is it a Raspberry yet? I probably have to power cycle the Raspberry. I don't think it'll detect an HDMI hot plug after boot. Didn't realize this was going to be desktop-y. I think this is the same Raspberry image I was using for the wiggling robot experiments earlier, so there might still be some stuff from that here. $144, huh? This is not... I guess I might have re-imaged this Raspberry since using it for firmware development. It's also possible that that's what this other micro SD card here is. I should really label my Raspberry Pi images if I plan on keeping them. I think the problem is I often don't really plan on keeping them, but maybe I really should. Let's try booting off this other card just to see if that's useful, and maybe I'll just end up having to start over. Oh gosh, that's a really big micro SD card. Hey there, train. Starting terminate Plymouth boot screen. Oh, this was the, okay, hub, right. This was the one for the Big Clown IoT hub. Let's keep that separate. Alright, let's go back to that 128 gig. Why do I need 128 gigs? I should use this SD card for camera footage, not for Raspberry. Oh, heat shrink on the end. Oh, that's neat. For labeling SD cards. Yeah, I might have to come up with a color code scheme where I, like, put stripes on the end with fingernail polish. This looks like I've recently re-imaged this Raspberry. That's fine. Oh, let's find that here. This is what I wanted, right? I just wanted it to give me the SSH URL, but I guess I can type that in myself. I don't know how much just like getting this computer set up I want to do right now versus just patching the firmware. I thought I already had a Raspberry that was set up for this, but I think I might have overwritten that with something else. Do Do you ever just like completely space out on the syntax of something you've probably typed a whole bunch of times? And I'm like, I'll just look at how this is checked out on the other machine, and like, why is this using an HTTPS checkout? Wasn't it like... Oh, am I really on UK layout also? Oh. I remember having this problem where I would change the keyboard preference on the Raspberry and it wouldn't stick. Are we still gonna have that? Yeah, well, I can just switch the remote later. This is not something I feel like messing with right now. I keep typing git cone. Get all the platonic solids. I didn't put like build instructions here, did I? Getting the submodules. What is that link? Something to track Tuco with. Oh. Yeah, that seems like it would involve a lot of data labeling, but this does look interesting. I've seen like markerless tracking for humans before, but this looks like it's a more general framework where it's easy to label new data. That's cool. I'm just installing the ARM toolchain here. What was it called? Oh, that's cool. 200 frames for good results. Alright, I'm just installing cross compilers. Even though the Raspberry Pi is using an ARM, but ARM for an embedded system is still a cross compiler because the native compiler assumes you want a Linux operating system interface. You could probably concoct a set of compiler flags that you could give the Raspberry Pi's built-in GCC that would produce good embedded binaries, but you're better off getting a compiler that's actually built for the thing you're using it for. We have a good text editor here. I think there's gedit, which is alright. Maybe we don't even have gedit. We have Vim. We have Vim. Alright, Genie is the editor that the Raspberry Pi comes with, which is alright. Waiting on the unpack. Cool. Denny's wondering why I'm developing the firmware on a Raspberry Pi. Otherwise, I would need a really long USB cable to run around the room and flash all the devices. I should actually plug this into a battery and not be using wired Ethernet, actually, now that I think about it. Okay, I should move this over to here next time I feel like shutting it down. Can we has compile? So this is compiling the winch firmware. It's written in C. It's a bunch of my own code plus a bunch of code from this kind of open source friendly derivative of TI's example repository for this. So it's basically the open source networking stack LWIP plus some of TI's code to glue LWIP onto the particular Ethernet hardware in this chip, plus some basic startup code, and then all of this is the application-specific code. So it looks like that built. We could, this is not my code, the code that's generating this warning. We could go in and patch that to not give us a warning, maybe. I don't know if it's worth it, but we could. Alright, so I'm gonna shut this down so we can run on battery power, and then let's think about actually editing the code here. I should also remember to set my Git identity before I actually commit anything. Because I was just imagining, like, oh, maybe I'll just, like, push these changes to my other machine. Not worry about setting up a separate set of keys. Why are you still flickering? Come on. Oh, right, shut down. And so I actually have to unplug this before it'll switch channels. Okay, battery power and Wi-Fi this time. Oh yeah, let me set up the Wi-Fi here. I'm waiting for it to scan for access points, and it sure is not giving me anything yet. Oh, computers. I just really don't like having multiple completely distinct modes in this robot. Like anytime I can have the modes, like I mean sometimes modes are a useful concept, but like if they have rigid boundaries, then I'm just gonna like cause oscillation around those boundaries, or the discontinuities are going to mess up my motion in some way. Why are we not finding any Wi-Fi here? Oh, here we go. It was just taking a while. Oh, cool. Yeah, we're on the network now. Okay. And we can build the firmware. Can we install the firmware? There was another package I might need to install for that. I think it was like LM4 tools. Oh yeah, Tiva. I don't know if I even had a makefile target for that, but I think the tool is LM4 Flash, and I think it was in Ubuntu. It's like LM4 tools or something. LM4 Flash. Can I open a whole directory in Genie? been using Sublime a lot, but it's not free. It is like basically shareware, so I wouldn't expect it to be in Ubuntu. I mean, I was missing the feature where you get like a sidebar that gives you a directory listing and you can easily switch between files. Maybe there's a different way of getting there. I don't think I can open a whole directory. Well, that's fine. What I really wanted was the protocol and maybe winch.c. Okay, that's not actually the protocol, that's just... Okay, I want protocol defs.h. I guess I can give like, because this program is returning. This command line genie is just telling the UI to open something new, so I think I can just call it like this. Winch.c? Sure. Winch.star? Sure, okay. I could just give it star, probably. Sorry. One of my goals here has just been to keep this protocol really simple so that I don't have to mess with the firmware very much. I can mostly just work on bot controller and stay there. This is maybe the response structure where I want to indicate the status of the dead zone. I'd probably want to make that a 32-bit field, even though I'm only using 1 bit. Whatever. And this, I mean, this might be the root of the problem here, that this is using an instantaneous velocity. Like, being in the deadband requires both of these conditions to be true. And the problem I'm having is not, like, insufficient deadband application, it's like false positives. Like, detecting that we're in the deadband when we really should just be passing through that 0 velocity point causes those little intermittent stutters across that 0 crossing, which is bad. The opposite, like having a false, like, you know, having, like, failing to detect the deadband when we should. The problem there, I mean, it's kind of bad too. It's like maybe a little bit less bad, but it would typically involve the motor like staying kind of stuck at a particular activity level. It wouldn't quiet down. really the velocity deadband is much more important than the position deadband. I mean, both are necessary, because imagine if we only had velocity and then you just suddenly changed position, but the motor is still not running. You just tell it to go somewhere else. So right there, you just have no impetus to get it started there. It stays in the dead zone because it stopped, and the motor wants to be stopped basically, but we're neglecting that it actually needs to move to resolve a position error. So this is necessary, but I don't think we need any additional filtering or hysteresis on it necessarily. And then the velocity. Like, the reason to have that velocity at all and not just the position. Well, okay, now I'm just thinking about that. I think that would... One problem that would result in is if we did not have the velocity deadband, only position. If you're slowly crossing that zero velocity axis, it could just stop. Because, like, momentarily, so the point here is if you're changing directions. Like, if you're moving here, then you're reversing directions at that inflection point, where the velocity is close to zero, you could just end up stopping. Yeah, I mean, I'm imagining one solution to this would be hysteresis, like I was thinking. Another solution would be to filter the velocity. I don't like adding another filter, especially something that's just used for this purpose. Yeah, who else is filtering the velocity? I mean, we've got filtered velocity error, which is similar. I could get to something kind of like the instantaneous, or like a filtered velocity. Alright, I need a brief restroom/coffee refill break, but I'll be right back. In the meantime, you can stare at Tuco. Aw. Nick and Lat on Twitch said they like my cat. Cat looks happy. Wonder what he's thinking about. Yeah, I often wonder what Tuco's thinking about. Sometimes it's pretty obvious, but sometimes it's more of a mystery. He's probably pretty sound asleep right now, maybe dreaming. I still feel like I don't quite understand this problem well enough to know exactly what fix I want to make here. It'd be interesting to try maybe experimenting with that other extreme where we just don't have this dead zone, and so we might end up with winches that kind of get stuck in a state where they aren't quite all the way off, but we wouldn't get this particular oscillation. It might be just interesting to try that. I don't think we want to keep it in that state, but... You know, I need to plug this HDMI cable into the Windows machine again, which maybe means I should make sure I can SSH into this Raspberry from elsewhere. I might have already set this up. 184, huh? I might have not turned on the SSH server. Oh, just a sec. Looks like a friend might need some last-minute help with something today. I'm trying to figure out what's going on, but if that's the case, I might have to end this early. Sorry about that. Which throwaway password did I set on this particular Raspberry? Or is it still the default? That's embarrassing if I get this set up and then I don't remember what password. Gosh, really? Sorry about the multiple problems here. Okay, I think things are fine for the moment, but I might wrap up soon. Oh, I'm having bad luck with computers today. Got gosh. Okay, well, I was going to try to save myself some time later, but let's go back to plan A.5 or wherever we were. Let's steal this HDMI cable for the Windows machine again. I'm used to being quiet when I'm over here plugging in cables because I'm usually far away from the microphone, but with the wireless microphone I can talk to you from anywhere. Okay. So much of this is just calculated on the bot controller side for the PWM specifically. Okay, deadband position error, deadband velocity. This is unfiltered deadband velocity. I just don't see where that could ever be good. Like unfiltered velocity being thresholded against a set parameter. Like, no. I'm wondering if maybe instead of having separate deadbands for position and velocity, I could somehow do it all using the filtered position, because I do have a system for that. Can I reproduce the problem right here? This is what, bot 0. Not on bot 0, apparently. Kind of have to like rotate the bug around. It's like as I move the winch, or as I move the robot, the problem kind of moves between the winches in the room. You can see these little sections where one particular winch is oscillating, but then sometimes you see a fluctuation that looks like that winch is oscillating, but really it's a different winch that's oscillating much worse, and then you're just transmitting the vibrations through and seeing it in the velocity sensor on the other winches. Could I reproduce this problem in single winch mode? Is that even a thing I could do? Oh, it is reproducible in single winch mode. That is much simpler. Okay, we might not be able to get a good video feed here. But manual winch 0. It's just impossible to move it smoothly at a slow speed, which is the root of the problem here. well, not the root, but like the most important symptom of the underlying problem, which is then causing everything else to spiral out of control. That certainly makes the robot oscillate when it does that. Okay, so first of all, let's just rule out the PWM frequency stuff. I don't think that's really a problem right now, but it'd be nice not to have to worry about that. Let's use like basically the same PWM frequency all the time. Huh. It is actually a lot less oscillaty with a fixed PWM frequency. I wonder if that's a coincidence or not. Like, the problem is still clearly there, but it's not happening as much or as badly. What if the frequency is just overall lower? That is actually pretty responsive. Oh, that's the minimum force limit that I was just hitting, which is why it cut off abruptly. And that's the maximum limit. Okay. It's moderately high up. Well, actually, in light of this new evidence, perhaps the PWM oscillation was more... Like, I mean, The problem exists regardless of whether the PWM oscillation is making it worse, but I'm surprised that it seems like the PWM oscillation was then making the position error dead zone oscillation worse, like those two might have been interacting with each other. You can see the sandbag moving around at this angle. That's my counterweight correlated with the noise hitting the camera. Okay, what are they all, like if I go back to multi-winch mode. Okay, back in multi-winch manual mode. What if we just bump up the PWM so that it isn't audible now? Like, I think the main problems that this will have now is that it's not going to be very responsive at like starting from a stop, and it's probably also going to have trouble completely stopping. Like, I'll worry about the motors using energy even when they seem to be stopped. And it's still having trouble with force leveling, but that's of course expected because we didn't change anything related to force leveling. It's really easy to change speeds too quickly and end up causing it to sway a lot. Okay, where are the PID contributions for each winch now? Okay. Well, maybe the dead zone isn't completely ineffective. Like, that actually seems alright. Oh, I think that's the joystick being not quite in its dead zone. Okay. Oh yeah, a little bit of oscillation. And it does eventually hit 0. Yeah, that actually, which winch is that? This purple one here? That is not actually it being stuck outside the dead zone. That actually is the force leveling happening really slowly. So like that line was a little bit slack and it was pulling in some of the extra tension, or extra slack, adding tension. What is it doing now though? So if the PWM is audible, I think we'd be hearing it beeping. Like, I think this would be super annoying if we could hear the motor right now. The motor is not turning off completely and it's just oscillating. Oh, it'd be cool if some of those charts had legends. There we go. So it's winch 1, I can't hear anything from winch 1 because the PWM is outside of my range of hearing, at least. That's interesting. It seems like as I brought that frequency down, we got enough torque or something. Okay, well that was definitely audible. Like, I can hear that. It's pretty annoying. I'd really like for this camera to be able to move around slowly and quietly. And so if I can get, like, ideally, you know, the PWM shift, like, it should happen only when necessary. Like, I'd want the motors to typically run at a high enough frequency that they're completely quiet. But then if they need to use a different frequency to overcome static friction for startup, they should be able to do so briefly. So one way to think about that would be, I mean, I think right now I was trying to kind of code that like a dead zone, but maybe I could think about coding it almost like a boost or something, like like it's something that typically you only run at one PWM frequency, but if you notice that you're over some threshold of stuckness, then you can kind of fill a bucket with, you know, some kind of consumable that allows you to use the lower frequency for a time. Johnny's wondering if the noises are annoying Tuco. I mean, so far he hasn't seemed to care about the robot, so I assume not, but yeah, I'm trying to be sensitive to that if I notice him caring at all. Okay, well, what else are we doing here? I feel like I'm just like thinking about this, trying to formulate a plan. This is single winch mode. Yeah, the slow, smooth movement is pretty nice, like when I can manage that at least. This is less stable than normal because it's effectively only on 3 chords right now. I'm driving it in manual mode, and the winch in that corner has tons of slack right now, because it's just hard to drive it on 4 chords in manual mode. At some point it starts picking up traveling waves from the slack rope as that one regains tension. There's also just a lot of other kind of orthogonal stuff to work on, like coordinate system stuff, so that I can drive it in a mode that's relative to where the camera's pointed rather than where the robot coordinate system is. More coordinate system type stuff for calculating the robot's height above the ground, even though the sensors are on a moving platform. We have an IMU that tells us where the sensors are pointed, and we can use that to gather kind of a statistical estimate of where the height above the ground likely is. So, something like that. Yeah, well, I think this might be a good point to wrap up the stream soon. Because, I mean, this could be just kind of like a rambly sort of investigation. Oh, sorry. I mean, this has been pretty rambly so far. Yeah, see here, I've left it alone, and the motor is not returning to 0 because the dead zones are not effective right now. That's like the flip side of this, right? It's like if the dead zones kick in overly often, then we get the chatter, and if the dead zones don't work when they're supposed to, then the motor gets stuck at like 20% power, which is not good. It looks like the position error is 0.04-ish. So I could also get this motor to shut down by turning this up past that. That's actually pretty big though. This is in meters. It's like 4 centimeters. Oh, that's not too bad actually. I should maybe make the range for this slider a bit wider. And why is this meters instead of meters per second? Yeah, that all needs work. Alright, well thanks so much for stopping by. Sorry if that was like not as directional as you were expecting. Some of the streams I guess get kind of rambly, but it was nice to hang out. I think some of us were fine with just like more of a rambly cat-oriented stream. I just haven't been thinking about the specific problems to solve in Tuco Flyer that much the last few weeks, and it's nice to get back into that. Look at some of the data together. Well, cool. Thanks for stopping by, and special thanks to everyone on Patreon who gives me a couple bucks to keep the shop running every month. All that adds up to this video experience that you are now participating in. So, if you do like this, then if you kick in a little bit on the Patreon, it helps me keep this going. And if you do contribute, then I'd be really happy to hear more from you about like what you want and what you'd like me to focus on, since I always feel like this is a bit of a variety show, and as much as I like variety, it's always nice to know which parts of it people are really resonating with, because there's just so much there otherwise. Alright, see you all next time.